Okay, here's the third and final study guide video for our trigonometry test. So we'll start with number 13. Use the trigonometric ratio to sketch a right triangle and solve the triangle. So this says sine A equals 1/2. So over here on the example, it walks you through what you're supposed to do. So you have to, first of all, you got to draw a possible triangle to figure this out. So you can see a right triangle is drawn here, and it says the sine of A is 1/2. So here's A, and sine is opposite over hypotenuse, so opposite 1/2. So now that we know that information, you just solve it like the ones from before. So we know that x is the square root of 3. You could use trigonometry, or remember in a 30, 60, 90, the long leg is the short leg, which is 1 times the square root of 3. And then you could also do Pythagorean theorem for that as well. And then also right here is how you solve the angles, which I'll do in the next one. Okay, so again, we have to draw pictures. So I'm going to draw a right triangle, and what do I know here? I know that cosine B, so I'm going to make this B. I could also have made this angle B, but I could not have made the 90 B because we can't look at the triangle from the 90, remember? So cosine B is 3/5. So remember, cosine is adjacent over hypotenuse. Adjacent over hypotenuse. And now we need to solve for the missing side and then angle B itself. So the missing side, I would use the Pythagorean theorem, which would be 3 squared plus x squared is 5 squared. And then I'd have 9 plus x squared is 25. And then I would have x squared is 16. And then the square root of 16 is 4. Now the only thing I need is angle B. So remember, with angle B, you're going to use the inverse. So if I look at this from angle B, again, because that's the angle that I want, I would ask myself, okay, well, what is 3 from angle B? It's the adjacent. And what's 5? It's the hypotenuse. So which one is adjacent and hypotenuse? It's ca. So what you do is you do second cosine, or cosine -1, and then you go 3/5. And when you put this into your calculator, it'll give you the answer. And what's really going on there is your calculator is, the cosine of angle B, so what is angle B when the adjacent over the hypotenuse is 3/5? And this is how your calculator figures it out. And when I do second cosine 3/5, so second cosine, and again, I don't know why this calculator does that. I'm sure I'm just hitting the buttons incorrectly. Maybe if I do the -1 first, does that do anything? Not really. Okay, second cosine. There we go. 3/5. That gives me 53.13 degrees. So that makes, here's that, and then angle B is 53.13 degrees. And then I would get this angle here by just subtracting from 180. Okay, let's do just a couple more. So let's do tangent B of 6/7. So I'm going to draw my right triangle. And let's put B up here this time. Okay, so B is up there. Tangent is TOA, remember? Opposite over adjacent. So opposite, that's opposite B. This is adjacent to B. Okay, so that's the setup for the triangle. And then I could use the Pythagorean theorem to get x. So 6 squared plus 7 squared is x squared, which would give me 36 plus 49 is x squared. And then this is 85 is x squared. And then it's just the square root of 85. And let me type that in here real quick. Square root of 85 is 9.22. So x is 9.22. And then I'm going to get angle B itself. So if I'm looking at angle B, What's 6 from B? It's the opposite. What's 7? It's the adjacent. So I would do, that's tangent, so I'd do second tangent 6 over 7. Make sure my calculator is in degrees. And then that will give you the angle measure. And then if you wanted to do this another way, let's say you didn't want to use 6 and 7. Let's say you wanted to use 6 and 9.22. Well, if I'm looking at angle B, what is 6? It's the opposite. And what is 9.22? It's the hypotenuse, which is sine. So I could have also gone sine -1, 6 over 9.22. And these two should give you the same number. Now, they're going to be slightly different because we rounded 9.22 to something. But watch, they're going to be real close. Now, if I were to do this and I were to get something different, I either made a mistake or my calculator is in the wrong mode. So let's do, let's see if I can figure this out. I think that's what they want you to, so frustrating. There we go, tan -1, 6 over 7. Okay, that gives me 40.6 degrees. Now watch, we're going to get something close to that, but a little different. So, sine -1. 6 over 9.22. And I get 40.59, essentially the same number, and we explained the small difference. So now that I have this is about 40.6, I could subtract from 180 to get this angle, and then I would be done. So I think you should be able to use that information to get the rest of them. Again, the key, I'll just do 18, is putting the angle in there and then deciding, okay, opposite over adjacent because it's tangent, and then solving for this and this and this. Use the right triangle below to determine which of the following are equivalent. Please also show the ratios expressions in each case. Very good. Okay, so this says sine A is A over C. Okay, so here's A, and we got opposite over hypotenuse. What's cosine of A? Well, that'd be adjacent, which is B, over hypotenuse, which is C. And then tangent of A would be, what's opposite A? That'd be A. And then over the adjacent, which is B. And now we're looking at it from angle B. So from here, the sine of B would be the opposite over the hypotenuse. The cosine of B would be the adjacent over the hypotenuse. And the tangent of B would be the opposite over the adjacent. Okay, that first part is pretty easy, which is why I went pretty quick without a lot of explanation. If you were confused on that, you could look at previous videos that I've done on trigonometry. Okay, so this says what's sine A divided by cosine A. Okay, so you want to take the values that you got up here and divide them. So what was sine A? And we want to divide that by cosine A, which was B over C. I like to think of it this way. This is a little too many fractions for me. I mean, I understand it, but I just like doing it like this. And then there's a review of fraction or division over here. So remember, that's A over B. Division becomes multiplication. And then you do the reciprocal of the next one. And then what that gives you is, that gives you, hold on a second, A over B divided by tangent. Oh, this is just a separate example. See how tan A doesn't match there? This is just a random example, I think. Okay, so for this actual problem where we're doing this, we would get AC over, hold on, I'm going to redo this. Okay, so we got this, and that's going to equal A over C. I think I might have written B. This becomes multiplication, and then we do the reciprocal of this one. And then A times C is AC. C times B is CB. And then our c's cancel out because c divided by c is 1. So whenever you have the same letter on the top and the bottom, they cancel. Okay, the next one is 1 divided by tangent a, and then an example is given for you. You might try this on your own. But 1 divided by, what was tangent a? Is a over b. So what's 1 divided by a over b? So you might think of that as 1 over 1 times, and then the reciprocal, and that would give me b over a. All right. Number 27 just says 1. Remember that any quantity divided by itself is 1. I'm not going to make you worry about these last 4. Just take it up to here, which it looks like I did for this entire section. So hopefully you found that helpful.